National Electrical Code NEC 700.12 B2 states that emergency panel boards, including automatic transfer equipment for emergency systems, shall be located in an area separate from and not subject to the same fire hazards as the normal power panel board. NEC 700.12 B2 B states that where the normal power panel board is located in an area where a fire could occur, the emergency panel board shall be separated from the normal power panel board by at least 6 feet, which is 1.83 meters, or by a fire-resistant barrier having a minimum fire resistance rating of 1 IR. NEC 700.12 B2 C states that where the normal power panel board is located in a room or enclosure that is not subject to the same fire hazards as other areas of the building, the emergency panel board may be located in the same room or enclosure. The International Fire Code, IFC 507.84.1 states that emergency electrical systems shall be located in areas separate from the normal power system or systems. IFC 507.84.2 states that emergency electrical panels shall be located at least 10 feet, which is 3.5 meters, from any other electrical panel or transfer switch. NFPA 110 Standard for Emergency and Standby Power Systems, NFPA 110.4.53.31 states that emergency switchboards, panel boards, and transfer switches shall be located in a separate room or area, which shall be isolated from all other rooms and areas. NFPA 110.4.53.32 states that the separation required by 4.53.31 shall be not less than 6 feet, which is 1.83 meters horizontally, and 10 feet, which is 3.5 meters vertically. Therefore, firstly, the National Electrical Code addresses separation based on fire hazards. If the normal power panel board is in an area susceptible to fire, a separation of at least 6 feet or a 1 IR fire-resistant barrier is required. If the normal power panel board is in a less hazardous area, the emergency panel board can be in the same room. Secondly, the International Fire Code mandates a minimum separation of 10 feet between emergency electrical panels and any other electrical panel or transfer switch. Thirdly, NFPA 110 requires emergency switchboards, panel boards, and transfer switches to be in a separate room or area isolated from all others, with a minimum separation of 6 feet horizontally and 10 feet vertically. To summarize, these codes provide a layered approach to ensuring the reliability of emergency power systems. The NEC focuses on fire hazards and uses separation or barriers to mitigate risk. The IFC sets a minimum distance requirement for separation. NFPA 110 provides the most stringent requirements, mandating a separate room with specific horizontal and vertical separation distances. Understanding and adhering to these codes is crucial for ensuring the safety and reliability of emergency power systems in buildings. Proper separation minimizes the risk of a single event such as a fire, compromising both normal and emergency power systems. This, in turn, ensures that essential functions such as emergency lighting, fire pumps, and critical equipment remain operational during a power outage or other emergency situation. For instance, consider a hospital where emergency power is vital for life support systems. The codes discussed ensure that if a fire breaks out in the normal power room, the emergency power system remains unaffected, allowing doctors and nurses to continue treating patients. Similarly, in a high-rise building, emergency lighting and fire pumps rely on emergency power. By separating the emergency power system, these critical functions can continue to operate even if the normal power system is compromised. The specific requirements of each code may vary depending on the application and local regulations. Therefore, it is essential to consult with qualified electrical engineers and code officials to ensure compliance with all applicable requirements. In addition to the separation requirements, the codes also address other aspects of emergency power systems, such as the sizing of generators, the type of transfer switches required, and the testing and maintenance procedures. A comprehensive understanding of all these requirements is necessary to ensure the reliable operation of emergency power systems. Furthermore, The selection of appropriate fire-resistant barriers is critical when physical separation is not feasible. These barriers must be rated to withstand fire for a specified period, typically 1 hour or more, to provide adequate protection for the emergency power system. The installation of these barriers must also be done correctly to ensure that they provide the intended level of protection. Regular inspections and maintenance of emergency power systems are also essential to ensure their continued reliability. This includes testing the generators, transfer switches, and other components of the system to verify that they are functioning properly. Any deficiencies identified during these inspections must be promptly corrected. In conclusion, the codes discussed provide a framework for ensuring the reliable operation of emergency power systems by requiring separation from normal power systems. Adherence to these codes, along with proper design, installation, and maintenance, is critical for protecting life and property in the event of a power outage or other emergency situation. The separation requirements are not merely arbitrary rules but are based on sound engineering principles and real-world experience. They are designed to minimize the risk of a single event disabling both normal and emergency power systems, thereby ensuring the continued operation of critical functions during an emergency. When designing an emergency power system, it is essential to consider the specific hazards present in the building and to select the appropriate level of separation to mitigate those hazards. For example, in a building with a high fire risk, a greater level of separation may be required than in a building with a lower fire risk. Similarly, in a building with sensitive electronic equipment, additional measures may be necessary to protect the emergency power system from electromagnetic interference. The codes also recognize that there may be situations where strict compliance with the separation requirements is not feasible. In these cases, the codes allow for alternative methods of protection, such as the use of fire-rated enclosures or automatic fire suppression systems. However, these alternative methods must provide an equivalent level of protection to the separation requirements. Ultimately, the goal of these codes is to ensure that emergency power systems are reliable and can provide power to critical functions when needed. By adhering to the separation requirements and other provisions of these codes, building owners and operators can significantly reduce the risk of a power outage disrupting essential services and endangering lives. It is worth noting that the codes are constantly evolving to reflect new technologies and best practices. Therefore, it is essential to stay up to date on the latest requirements and to consult with qualified professionals to ensure compliance. In addition to the codes discussed, there may be other local regulations that apply to emergency power systems. It is important to check with local authorities to determine the specific requirements in your area. For instance, some jurisdictions may have more stringent separation requirements than those specified in the national codes. The enforcement of these codes is typically the responsibility of local building officials and fire marshals. They will inspect emergency power systems to ensure that they comply with the applicable requirements. Failure to comply with these requirements can result in fines, penalties, and even the shutdown of the building. Therefore, it is essential to take these codes seriously and to ensure that emergency power systems are properly designed, installed, and maintained. By doing so, you can protect your building, your occupants, and your business from the devastating effects of a power outage. The selection of appropriate equipment for emergency power systems is also crucial. This includes generators, transfer switches, batteries, and other components. The equipment must be sized correctly to meet the load requirements of the critical functions that it will power. It must also be designed to operate reliably under emergency conditions. In addition to the technical requirements, the codes also address the administrative aspects of emergency power systems. This includes the documentation of the system, the training of personnel, and the development of emergency plans. Proper documentation is essential for ensuring that the system can be properly maintained and repaired. Training of personnel is necessary to ensure that they can operate the system correctly in an emergency. Emergency plans are needed to coordinate the response to a power outage and to ensure that critical functions are maintained. By addressing both the technical and administrative aspects of emergency power systems, these codes provide a comprehensive framework for ensuring their reliability and effectiveness. They are not just a set of rules, but a set of guidelines that are based on years of experience and best practices. By following these guidelines, you can create an emergency power system that will protect your building and your occupants in the event of a power outage. The cost of complying with these codes can be significant, but the benefits far outweigh the costs. A reliable emergency power system can prevent loss of life, injury, and property damage. It can also minimize disruption to business operations and maintain essential services. In conclusion, the codes discussed provide a critical framework for ensuring the reliability of emergency power systems. By adhering to these codes and by taking a comprehensive approach to emergency power system design, installation, and maintenance, you can protect your building, your occupants, and your business from the devastating effects of a power outage. Remember that these codes are not static but are constantly evolving to reflect new technologies and best practices. Therefore, it is essential to stay up to date on the latest requirements and to consult with qualified professionals to ensure compliance. Furthermore, it is important to recognize that these codes are not a substitute for good engineering judgment. In some cases, it may be necessary to go beyond the minimum requirements of the codes to ensure the reliability of the emergency power system. The best approach is to work with experienced electrical engineers who can assess your specific needs and design a system that meets your unique requirements. They can also help you to navigate the complexities of the codes and to ensure that your system is fully compliant. By working with qualified professionals and by staying informed about the latest requirements, you can ensure that your emergency power system is reliable, effective, and compliant with all applicable codes. This will give you peace of mind knowing that your building and your occupants are protected in the event of a power outage. Therefore, firstly, remember to consult NEC 700.12. B2. A. NEC 700.12. B2. B. And NEC 700.12. B2. C for National Electrical Code requirements. Secondly, adhere to IFC 507.84.1 and IFC 507.84.2 from the International Fire Code. Thirdly, refer to NFPA 110.4.5.3.31 and NFPA 110.4.5.3.32 from the Standard for Emergency and Standby Power Systems.